Okay, so we are in 3.1, forms of quadratic equations. So these are functions here, and we're going to write it in two other forms, as well as use those forms and the information in them to graph the quadratic function. So forms plus graphs. So this is what I have been calling transformation form, but also it is frequently called vertex form. Now it is the same transformation form that we would have seen like this for our absolute value function. So we can find the vertex from it the same way that we always have. We can set the thing inside equal to 0. X plus 2 equals 0 when x equals -2. So when x is -2, we have a vertex at that point, but we also have this downward shift. So the y value of the vertex is -8. We've been pushed down by 8. So we can come down here to -2, -8. And that will give us our vertex of our parabola. Now the difference is this was shaped like a V. This is going to be shaped like a parabola, more like a U. So we're not going to come to a sharp point, but we will have that point where we turn from left to right. The other thing we will also have is symmetry. So the axis of symmetry for this parabola is the x equals 2 or -2 line. It will always go through that vertex, and any point that we find that's to the left of it will also be to the right of it, etc. That's what the symmetry gets us. So now that we have the vertex from this vertex form, we are also going to multiply it out into other forms to find more stuff, right? This will also have a stretch of 2, but it's not as easy as saying it's a slope of 2, because if we go in a slope of 2, that would be drawing a straight V, but we want a curved U. So we're not going to count this one out just now. But it does have that vertical stretch of 2, so we also can't draw our standard parabola. So what we're going to do is multiply this out using PEMDAS. So the PEMDAS is do the exponent first, then the M is going to be this 2, this multiplying, there is no D, and then we're going to do the A and the S, which will be subtracting the 8. So I'm going to have a format here where I'm going to replace the x plus 2 squared with what it's equal to in standard form. I'm going to then multiply it by 2 and subtract 8. So let's look at that E, that exponent situation. I'm going to multiply out x plus 2 times x plus 2. This length is x plus 2, this width is x plus 2, so x plus 2 times x plus 2 will also give me the sum of each of these areas. I'm going to write the terms that are inside all added together here. And this is to move myself into standard form. I need to do all the multiplying out. So this box is x wide and x high. This is x wide and 2 high. This is 2 wide and x high. And this is 2 high and 2 wide. So I'm literally doing the multiplication to find the area of each of those rectangles or squares. Now I'm going to add those pieces together. The area that is x plus 2 times x plus 2 is also x squared plus, now I have 4 x's, right? There's even a plus here in the middle that says we're going to combine those, and then plus 4. Now, I'm getting there, but I'm not there yet. I'm going to distribute this 2 into this. I could even see it as, if I wanted to continue with the area model, I could say I am 2 high and x squared plus 4x plus 4 wide. So it's going to be 2x squared, right? This was a 2 times. So I'm multiplying by imagining that I'm too high and that wide. 8x and then plus 8. So I end up with 2x squared plus 8x plus 8. That's what was here. That is this now. This became this. But I still need to subtract my 8. So plus 8 minus 8 makes 0. And plus 0 gets to go invisible. So my standard form of the same function, f of x, it's the same function, will be 2x squared plus 8x plus 0, right? Now I can write the plus 0, there's nothing wrong with that. Now I can see that there's a c value of, like, a is 2, b is 8, c is 0, for what that's worth. But now I've got standard form. What does that get me? Well, the only thing that useless form is good for is finding what happens when x is 0. X is 0 is this line right here. X equals 0 is the y-axis. So when I plug in 0, I am finding the y-intercept. Well, 2 times 0 is 0. 8 times 0 is 0. And then 0 is 0. Well, so, the origin is a point on this function. But is it the vertex? No, I already found the vertex using my transformation form. It's just the y-intercept. It's where the function will cross the x equals 0 line. It is the output of 0 when I input 0. Every point on the graph is an input-output pair. So that is f of 0, and that's 1 point on the graph. Oh well. Now I'm going to try and find the factored form. The factored form of f of x will generally look like a times a factor, x minus something, times a factor, like this. This is my factored form format where I'm looking for the numbers that go in here. Now, my a I know to be 2. A is 2 here, and a is 2 here. So a is gonna be 2 here. Interesting. Maybe I can rewrite my standard form by factoring out the 2 from all of this. If I pull out the factor of 2, then I'm going to divide 2x squared by 2 and get x squared left. Divide the 8x by 2 and get 4x. And then the 0 is still 0. Okay, well, good, I'm closer. But I still have an x squared inside. I wanted 2 individual factors. So now what I'm trying to do here is find the box whose area inside is x squared plus 4x, right? Where that equals a positive 4x. Well, it's x and x, okay? But my c value would still be 0 here. How do I make an area of 0 by multiplying a height and a width? One of those must be 0. The only factors that make 0 are 0 and something else. It's called the zero factor property. It's a property of 0 that it wipes everything out. So if I have 0, I must have been multiplying by a 0 at some point, or adding to 0, but the multiplying is more interesting. The only way to make an area of 0 is for my rectangle to be 0 wide or 0 tall. I chose 0 wide just randomly. But if this is 0 wide, then this is 0 x's. 0 times x is 0. Well, then my 4x must go here. I need all 4 x's to be there. Okay, well, if all 4 x's are here, this is x wide, it must be 4 tall. So this is x plus 0 and x plus 4. This is my factored form. Now I'm looking for the values in order to graph this factored form, which will tell me what makes it equal to 0. This is y equals 0. This line here, the x-axis, is the y equals 0 line. So I'm looking for where on the x-axis will output 0. Since this is multiplication, well, 2 will never be 0, so that's not helpful. But what if this was 0? Or what if this was 0? If either one of these is 0, it's going to wipe out everything else, so it doesn't really matter what else I have. So I'm going to make my function 0 when x is -4, right? Because I'm going to subtract 4. Let's do it. 0 equals x plus 4, so x equals -4. Subtract 4 from both sides. I'm not moving things, I am doing something to both sides. Subtracting 4. And here, this is only true when x itself is 0. So that's here. Oh good, it confirms my y-intercepts, that I have an x-intercept at the same place. So now I connect my dots with a u. It's a very steep U because it's got that vertical stretch by 2, but I have 3 points that I can connect symmetrically, right? And there's my graph. My vertex is labeled. My intercepts might be labeled, -4 and 0 here. My axis of symmetry is labeled. So these are the kinds of things I'm looking for. I don't need these things because they were just informative stuff, but I want to clearly understand what my x-intercepts are, what my axis of symmetry is, label that line with its equation, and what my vertex's point is. And then I'm looking for my vertex form, my standard form, and my factored form. Now, I might be able to simplify the factored form a little bit. The factored form doesn't have to have an x plus 0 in it. It can just have an x. And usually when it just has an x, we put it in front. So I'm going to rewrite this as 2x times x plus 4. This is factored form. It's 2 is my a. X is one of my factors, and x plus 4 is another factor. That is a string of 3 factors, 2x and x plus 4. When I know what x is, I can plug it in and do all of that multiplication, right? When x is 0, everything's 0. When x is -4, everything's 0. But let's say we wanted to be more careful and plot the point here at -3, see what's happening so that we can get our shape just right. I'm going to plug -3. Honestly, I could plug it into here, or here, or here. It doesn't matter. I should get the same value out. I'm going to choose this one. So when I want to find f of -3, just as a guide point to see if it lands in the right place, I'm going to do 2 times -3 times, well, -3 plus 4 is 1, so it's at -6. -6, oh, how nice. I actually already went through those points. So I drew my U appropriately. Great, hope that helps.